Lesson 12-3 homework. Number 1. Suppose you start with a square piece of paper that you divide into 4 quarters, cutting out an L-shaped piece using 3 of the quarters and laying it down to create the first term of a geometric sequence. You then use the remaining quarter to repeat the process 3 more times. All right, so let's complete the table. Complete the table. So stage 1, you cut out this first, so that leaves you with 3 quarters. 1 minus 1 quarter is 3 quarters. Stage 2, you have 3 quarters plus 3/16. And that's going to give you 15/16. 1 minus 1/16 equals 15/16. So that's what this is. This is 1/16. And think about it. 1, 2, 3 fourths, and then 1, 2, 3, 4. So that would be a 16th. And let's do the next one. This right here. What is this? How big is that? How big is that? Well, let's see. You have 3 fourths plus 3/16 plus 3/64. And that's going to be 63/64. So this side, this piece right here, that is 1/64 of that that square. And then let's see, let's do this right here. How big is that? Well, let's see. You had 3 fourths plus 3/16 plus 3/64 plus, how big is that? That's going to be 3/256. And put those in the calculator and add them up, and you get 255 over 256. 1 minus 1 over 256 equals 255 over 256. Is there a common factor? 4 times 4 is 16. 4 times, that's 64. Okay. Generalize the results in the table. At stage N, the second column gives you the finite geometric series 3 fourths plus 3/16 plus yada, 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 plus 3 times 1/4 to the n power. The third column gives you a way to find the sum of this series. What does the third column give you? All right. So what does the third column give you? It gives you 3 fourths plus 3/16 plus, and that's going to be 3 times 1/4 to the n power, which equals 1 minus 1/4 to the n power. Show that the general formula for the sum of a finite geometric series agrees with the specific formula from part B. So the general formula is S of n is A times 1 minus R to the n over 1 minus R. And we'll let A equal 3/4, and we'll let N equal, or R equal 1/4. So S of N equals, and that's going to be 3/4 times 1 minus 1/4 to the N over 1 minus 1/4. And that's going to equal 3/4 times 1 minus 1/4 to the N over, and then 1 minus 1/4 is 3/4. So this and that will cancel out, and you're left with 1 minus 1/4 to the N. Okay? So that's how that third column worked. Number 2. In a later lesson, you will learn how to use polynomial division to show that x to the nth power minus 1 divided by x minus 1 equals x to the n minus 1 plus x to the n minus 2 plus so on and so on, plus x squared plus x plus 1 for any integer n greater than 0. Use this identity as an alternative method of deriving the formula for the sum of a finite geometric series with n terms. That is, given the series a plus ar plus ar squared plus and so on equals a times r to the n minus 1. Show that its sum is a times 1 minus r to the n over 1 minus r. Okay, let's see. I guess first we got this series here. We need to factor out the a's. We have a plus ar plus ar squared plus and so on plus ar to the n minus 1. We need to factor out the a's first. So that will give us equals a times, and it's going to be 1 plus r squared plus, and then it's going to be r to the n minus 1. Okay. Now, we need to replace the series with the identity. So we have a times r to the nth minus 1 over r minus 1. Okay. Now, let's multiply the numerator and denominator by -1, and we get a times 1 minus r squared over 1 minus r. And there we go. Easy peasy. Find the sum of the geometric series. Okay, so the formula, S of n equals a times 1 minus r to the n over 1 minus r. I'm seeing three variables, a, r, and n. So let's see here. A is going to be the first term, -3. R, we're going to take 6 divided by -3. That's going to give us -2. And let's see, 1, 2, 3, 4, 5, 6, 7, 8 equals 8. All right. So the sum of 8 would be -3 times 1 minus, that's -2 to the 8th over 1 minus -2. And we'll just put that in our calculator. So we've got -3 times, and we'll open parentheses, control, divide, and we got 1 minus, that's going to be -2, caret 8, and 1 minus, that's -2, and we can press enter. Get 255. So our answer is 255. Not too bad. Same process here. What is A? That's 6. What is R? That's going to be -4 divided by 6, which is -2/3. And 1, 2, 3, 4, 5. N equals 5. So S of 5 equals 6 times 1 minus, that's -2/3 to the 5th power over 1 minus -2/3. And we'll just go ahead and put that in the calculator. We have 6 times, open parentheses, control, divide, 1 minus -2, control, divide, 3, caret, what was that, 5, and then 1 minus -2, control, divide, 3, and then press enter. And that's 110 over 27, which is approximately 4.07. I'll make that approximately 4.07. All right, number 5. Determine how many terms the geometric series has. Okay, so it shows us what A is. We can calculate what R is, but we don't know what N is. So A equals -12. R equals, and that's going to be -4 over -12, which is 1/3. And we don't know what N is. All right. So we got to calculate what N is. Well, how do we calculate? We know that this is remember the beginning formula, f of n equals a times r to the n minus 1. We can use that formula there. All right. So this is going to be -4 over 243 equals a, which is -12, times r, which is 1/3 to the n minus 1. Okay, let's see here. If we divide both sides by 12, we're going to get -1 over 700. No, they're both negative, so that's 1 over 729 equals 1/3 to the n minus 1. 729. Let's see here. 3 caret, I'm going to just say 5. 243. 3 caret 6. 729. So that's going to be 3. That's going to be 1/3 to the 6th power equals 1/3 to n minus 1. So 6 equals n minus 1. 7 equals n. I added 1 to both sides. So n is 7. So s to the 7th, or n, is going to be negative 12 times 1 minus, it's going to be 1/3 to the 7th power over 1 minus 1/3. And let's put that in the calculator. So that's going to be negative 12 times 1 minus 1 divide 3, close parentheses, caret, what was that, 7? 7, and that's going to be 1 minus 1 control divide 3. Press enter. Negative. Wow, that looks funny. Why don't we control enter that, and we get negative 17.99. So let's put S of 7 equals negative 17.99. And that's approximately. There's a little bit more to it. All right, what about number 6 here? Well, we can see that A is 0.3, and then R that's going to be 0.03 over 0.3, which is 0.1, I believe. Let's see. 0.03 divide 0.3, I get 0.1. All right. And then N, we're not sure what N is. Okay. So what do we got here? We got 0.000. Let's see how many zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 3. And I bet that's going to be N equals 6. All right. N equals 6. So that's going to be 0.3 times 0.1 to the N minus 1. Divide that, let's see here. 0.1, 2, 3, 4, 5, 3. Divide 0.3. And that's 1. So that's going to be 0.1, 2, 3, 4, 5, 1. And that's going to be 0.1 to the N minus 1. So that's going to be 0.1 to the fifth power, because you got 1, 2, 3, 4, 5 to the fifth power, and that's going to be 0.1 to the N minus 1 equals, so that's that's going to be 5 equals N minus 1, so 6 equals N. So it was 6. Now let's see, S of 6 equals 0.3 times 1 minus 0.3 to the 6 over 1 minus 0.3. And let's just put that that's supposed to be 0.1. 0.1, and that's 0.1. Okay, that's supposed to be R. And let's see here. So we've got 0.3 times, open parentheses, control, divide, 1 minus 0.1 caret, and I don't remember what that was, 6. 6 over 1 minus 0.1, and we get 0.3 repeating, equals 0.1, 2, 3, 4, 5. All right, so there we go. That's 6. 7. This looks like fun. Big numbers. What is A? A is 6. What is R? That's 30 divided by 6. That's 5. What is n? Not sure. So we got 4, 6, 8, 7, 5, 0 equals 6 times 5 to the n minus 1. I wonder if nsolve will do that for us. Let's try that. So menu 3, 1, and then we've got what is it? 4, 6, 8, 4, 6, 8, 750, 0 equals, and then we're going to have 6 times, and we'll open parentheses, 5, close parentheses, caret n minus 1, and then we want to get down off of that, comma, we're looking for the n, and press enter. That gives us 8, and it does work. So n equals 8. So S of 8 equals 6 times 1 minus 5 to the 8th over 1 minus 5. And let's see here. So 6 times, open parentheses, control divide, 1 minus 5 caret 8 over, I need to get down on the bottom, 1 minus 5. And I get 585,936 equals 585,936. Not too shabby. Number 8, A equals -3, R equals, that's going to be 9 over -3, which is -3. Don't know what n is yet. All right, so let me set it up. -177, 147 equals -3 times -3 to the n minus 1. Divide both sides by -3, and I get 59,049 equals, and that's -3 to the n minus 1. Well, let's see here. How am I going to find that out? How about 3 caret, let's 7. That's not going to get it. 3 caret 9. That's not going to get it. 3 caret 10. That's what I'm looking for, 59,049. So I'm going to put -3 to the 10th power equals -3 to the n minus 1. So 10 equals n minus 1, 11 equals n. And you could have n solved and would have done the same thing. So S to the 11th will equal, we got -3 times 1 minus -3 to the 11th power over 1 minus -3. And let's see, what do we get? -3 times, open parentheses, and then 1 minus -3. You got to make sure you put that in parentheses. Caret 11 over 1 minus -3. And I get -132,861. -132,861. All right, not too shabby. Now let's see here. 9. Now we get to write the infinite geometric series from its given description and then find its sum. Okay, so it starts with 2. So A equals 2. And it ends with negative 6,000, has a common ratio of 5. So R equals negative 5. We don't know what N is. So let's see, we got 2, and then multiply that by negative 5, and that's minus 10. Multiply that by negative 5, and that would be plus 50. Multiply that by negative 5, that's minus 250. Multiply that by negative 5, and that gives you 1250 plus 1250. Multiply that by negative 5, that gives minus 6,250. So that's going to be 1, 2, 3, 4, 5, 6 terms. So n equals 6. All right. So S of 6 equals 2 times, that's 1 minus negative 5 to the 6th power over 1 minus negative 5. And that gives you, I'll put it in the calculator, and I got negative 5,208. Not bad, not bad. All right. Number 10, a geometric series of 5 terms that begins with 1 and has a common ratio of 1/3. So 1 plus, and then 1 times 1/3 is 1/3, plus 1/3 times 1/3 is 1/9, plus 1 over 27, plus 1 over 81. All right, so we know that A is 1, we know R is 1/3, and N equals 5. Now, I didn't really have to do this up here, just show you how it worked. So S of 5 equals 1 times, and that's going to be 1 minus 1/3 to the 5th over 1 minus 1/3. And if you put that in the calculator, you're going to get 121 over 81, which is approximately 1.49. That doesn't look real good, except 1/3. Can you see that better? Well, I'll tell you what, 1/3. That looks better. All right. There we go. So that's 10. 11. A geometric series with 7 terms that begins by 1,000 and successively decreases by 20%. Successfully decreases by 20%. So R is not going to be 20%. R is going to be something else. So we've got 1,000, right? All right. A geometric beginning. All right. Plus, and then let's see, 1,000 times 0.2, that's 200. So 1,000 minus 200 is going to be 800. Plus, and then 800 times 0.2, that's 160. So 800 minus 160, that's going to be 640. Okay. So are you seeing a pattern here? What are we actually, we're actually multiplying by 0.8. So 6 times 0.8, that's 512 times 0.8, 409.6. Okay. plus 512 plus 409.6. 1, 2, 3, 4, 5. And then we got two more. Plus times 0.8, 327.68, 327.68 plus times 0.8 and 262.144. Now, yes, since there's only 7 terms, you could add them all up. Or you can use the formula. A is 1,000. R is 1 minus 0.2, which is 0.8. N equals 7. So S of 7 equals 1,000 times 1 minus 0.8 to the 7th power over 1 minus 0.8. So let's add that up. Let's see here. 1,000 times, open parentheses, control divide, 1 minus 0.8 caret, and that was 7 over 1 minus 0.8. I get 3,951.424. 3,951.424. All right. A geometric series where the first term is -12 and the last term is -972. And each term after the first is triple the previous term. So let's see, we got -12. All right. And that's going to be minus because that's negative. Triple, that means 3, so that's going to be negative 36 minus, that's going to be 108 minus 324 and minus 972 minus, is that it? 1, 2, that's where we were going to, right? So we're done. All right, now, like I said, you could just add them all up. A equals -12, R equals 3, 1, 2, 3, 4, 5, N equals 5. So S of 5 equals, arrow, no. One minus 3 to the 5th power over 1 minus 3. And I get -1,452. Chess. The first international chess tournament was held in London in 1852. This single elimination tournament, in which paired competitors played matches and only the winner of a match continued to the next round, began with 16 competitors. How many matches were played? Okay. Well, what is A? And I know at first you're probably thinking 16, but it's 16 divided by 2, so there was 8 matches. It started out with 8 matches. And let's see, R equals 1/2, okay? Because half the people, the number of matches is half the people. We don't really know what N is, but we know that the last match has a 1. So F of N, let's see, F of N equals AR to the N minus 1. So F of N is 1, A is 8, R is 1/2, and then n minus 1. Okay. So that's going to be 1/8 equals 1/2 to the n minus 1. So that's 1/2 to the third power equals 1/2 to the n minus 1. So 3 equals n minus 1, 4 equals n. So s to the fourth equals 8 times 1 minus 1/2 to the fourth over 1 minus 1/2. And let's put that in the calculator. We have 8 times 1 minus caret 4 and 1 minus 1/2. Press enter. And we got 15. That equals 15. So 15 matches. 15 matches were played at that chess tournament. 16. A ball is dropped from an initial height and allowed to bounce repeatedly. On the first bound, one up and down motion, the ball reaches a height of 32 inches. So it was dropped. It was dropped. And boom. And then and on each success, it reaches 75%. So let's see up here, 75. And then 75. And then 75. And so on. Okay. What is the total vertical distance the ball travels in 10 bounces? So n equals 10. All right. How far it went? The first up. So this right here was 32 inches. So it went up 32 inches and it went down 32 inches. So A equals 64. So it went 64 plus 64 times 0.75 plus 64 times 0.75 squared plus 64 times 0.75 to the third power. And then it kept on, and that would have been 64 times 0.75 to the ninth power. Because remember, this is 10. So n equals 10. Now see where this formula comes in handy? Oh, I meant to put in plus 64, that's 0.75 to the ninth. So I don't have to write them all out. It follows that pattern. So we have s to the 10th equals 64, that's A, times it is 10, A isn't, and then that was supposed to be R equals 0.75, right? So 1 minus 0.75 to the 10th power over 1 minus 0.75. So if we put that in our calculator, we get approximately 241.6 inches. So the ball traveled 241.6 inches in its 10 bounces, which is about 20.1 feet. All right, not too bad. 15. During a flu outbreak, health officials record 16 cases the first week, 56 new cases the second week, and 196 new cases the third week. Assuming the pattern of new cases continues to follow a geometric sequence, what total number of new cases will have been recorded by the fifth week? So, all right, we got the first is 16 plus 56 plus 196 plus, and then we need two more, right? Okay, so there's three. So A equals 16, R equals, and that's going to be 56 over 16, which is 7 halves. 7 halves. And then N equals 5. So S 16 times 1 minus at 7 halves to the fifth over 1 minus 7 halves. And that's going to be 3,355 if you put it in your calculator. So a total of 3,355 new cases will have been recorded by the fifth week. Not too bad. B, how many weeks will it take for the total number of recorded cases to exceed 40,000? So, okay, let's see. We'll have to use AR to the N minus 1 equals F to the N. And we want to exceed that, so we'll have 16 times 1 minus, and that'll be 7 halves to the n power over 1 minus 7 halves. And we want it greater than 40,000. Okay? All right. This would be a perfect problem for n solve. But just in case you don't, you got 16 times, and let's see, 7 halves n minus 1. I'm multiplying this by -1, and I get, that would be 3.5 minus 1. That's going to be 2.5, 2.5, and that's greater than 40,000. All right. These two, that becomes 6.4 times, and 7 halves is 3.5 n minus 1 is greater than 40,000. Divide both sides by 6.4, and I get 3.5 n minus 1 is greater than 6,250. Add 1 to both sides, 3.5 n is greater than 6,251. We'll have to go to our calculator. 3.5, and we'll say to the fifth power is what? 3.5 to the fifth power. 3.5 caret 5. And that gives me 525.2 is 525.2. So let's jump up to 3.7. 3.5 to the seventh power. So 3.5 caret 7. That's 6433. 6433. That is greater than, and not by much, so that's our answer. N equals 7. So by the seventh week, it will exceed 40,000 during the 7th week. All right. And if you want, you can put 3.5 to the 6th power, and that'll give you 1,836. So you see what I'm saying? All right, we good. Finance. A person deposits $5,000 into an investment account at the end of each year for 10 years. The account earns 4% interest annually. What is the future value of the annuity after the 10th deposit? So it's going to be, the first year it's going to be $5,000. All right. And then the second year it's going to earn 4% interest. Plus you're going to put 5,000 in. That's 1.04. All right. The third year it's going to do the same thing. And it's going to be squared plus 5,000. 1.04 to the third, plus, and so and so and so. And we're talking about 10 years, so it's going to go to 5 plus 5,000, 1.04 to the 9th power. Okay. So A is 5,000. R is 1.04. And N is 10. So this is where the formula really shines. All right. And it's going to be 5,000 times 1 minus 1.04. I don't know why I did that. To the 10th power over 1 minus 1.04. And if we put that in the calculator, that comes out to approximately 60,030.54. So after the 10th deposit, it will be worth $60,030.54. Not too bad. A business wants to buy a parcel of land in order to expand its operations. The owner of the land offers two purchase options. Buy the land today for $1,000 or buy the land in 5 equal payments of $22,000, where the payments are due a year apart and the first payment is due immediately. Okay, well, it sounds like the second option, you're paying more. Okay, but the chief financial officer for the business determines that the money set aside for the purchase of the land can be invested and earn 5.4% interest annually. So now which one's going to be better? Which purchase option is better, is the better deal for the business? Explain. All right, so let's see, what do we got here? Well, first year that would be $22,000, right? Plus, and then the next year that would be 22,000, 1.054, and that would take the interest off, and then you got 22,000, 1.054, and that would be squared, plus 22,000, and that would be 1.054 cubed. And we got to go 5 years. 1, 2, 3, 4. So that would be 22,000 and 1.054 to the fourth. Okay, you could add those up or use the formula S to the sub 5 equals 22,000 times 1 minus 1 over 1.054, and that would be to the 5th power over 1 minus 1 over 1.054. I'd put that in the calculator, and I get $99,291.48. So the delayed option saves the company about $708.52. So the delayed option would be the better option. All right. Let's see here. 18. That'll be part of your homework, but I'm not going to give you the answers right here. Okay. Y'all have enjoy your day, and I will see you tomorrow in class.